If we had discussed the production potential, okay, then let us discuss the working of the electrochemical cell. Let us suppose we have these two arm cells. The electrochemical series is fine. That we have discussed now. Is clear? Let us suppose this is zinc in zinc sulfate. One molar, and this is copper in copper sulfate solution. Okay, concentration is here also 1 mole. Okay, now we make the connection through voltmeter. Okay, the electrodes are connected. The oxygen half cell and production half cell also they are connected through the salt bridge. Okay. Now, in this case, the deflection will be seen. Okay. And the voltage that we get here is 1.10 volt. Right? This is your zinc. In zinc sulfate solution, 1 molar we have taken, 1 molar we have taken. Okay. So the potential that we get here will be your standard cell potential. Right? Now, in this case here, this one is acting as the oxygen half cell. Okay, everybody is undergoing oxidation. This is negatively charged. Okay, this will be your anode here, and the reduction is taking place here, and this is your cathode. Fine. The direction of electronic current is this one, and the direction of the conventional current is in this left road from right to left. Okay. Now, what is the cell reaction which is taking place here? The oxidation half reaction, and here I like the reduction half reaction. Okay. The anode reaction is zinc is going into the solution at zinc ion. Thus, 2 electrons getting removed, and here copper. This is the reaction at the cathode. Okay. Here copper plus is taking up 2 electrons and depositing as copper solid. This is the reaction which is taking place at the cathode here. Fine. Now, the overall reaction can be found by adding these two. The left hand with left hand and right hand with right hand. Okay. So this is the construction. Okay. This is the construction of the electrochemical cell, and the voltage that we obtain here is 1.1 volt. Okay. And how do we get that? I'll show you that also. So I hope you have understood. So E naught cell equals to E cathode minus E anode. Okay, standard. We have standard here. Okay. So here, what is the E cathode? Cathode is your copper. Okay, it is minus 0.34 volt, and then the zinc standard reduction potential for zinc is your minus minus 0.76 volt. Okay. So the cell potential that we get here is add this to 0.34 plus 0.76. It works out to 1.10 volt. Okay. This will be the cell potential when we have the copper connected with the zinc. Okay. Now remember that in the case of the this is done copper is in case we have the electrochemical series. Okay. This is the electrochemical series in which we have the reduction potential of the various what do you call it ions, okay, or the elements. If we have to construct an electrochemical cell, okay, then remember that the one which is toward the bottom, okay, the one which is toward the bottom or lower, rather lower is better word, okay, that should always be taken as the anode, okay, and the one which is above is always taken as the cathode. If this is how the construction of the electrochemical cell is done, or the galvanic cell is done, then the cell will function if you reverse the electrodes. Okay, if you make this one as the cathode and this one as the anode, the cell will not function. Fine. So for the cell to function, it is mandatory, or it should be kept in mind that the one which is lower in the electrochemical series, okay, that should be made the anode, and the one which is above, that should be made the cathode. Fine. Then only the cell will function. Otherwise, the cell will not function. Okay. This is done. Done. इतना ही थोड़ा सा याद रखना चीज था, ठीक है? Now, here the overall reaction. At time you are just given the reaction and you are told to construct the electrochemical cell, okay, and find out the cell potential. I was just putting that to be just 1 mark, okay, but hardly it is given, okay. Basically, the questions are asked from the university question rather than asking you the simple, what do you call it, finding out the cell potential. Right? Now, overall reaction is add these two. Okay, so zinc is combining with copper 2 plus to form your zinc ion plus. This is the overall reaction. Okay, and how do we represent the cell? Remember that whenever we have to draw or represent the cell reaction, the anode is toward the left and the cathode is toward the right. This is by convention, okay, that we need to follow while we are constructing the galvanic shell. Okay. Now, how the cell is represented? Whatever the reaction is taking place, the same is written here. Okay. Okay. Zn solid 2 Zn plus plus. Okay, this is the anode, right? And the cathodic reaction is Cu plus plus. Of course, here 1 molar, and here also it's 1 molar, or you may write aqueous, fine. And it is being converted to getting reduced to the copper. Okay. So the oxides form is at the center, and the reduced form are at the edges or the corners. Fine. And this is the oxygen half cell, and this is the reduction half cell, and they are separated by the solvents. That is double slash. This is how the cell is represented. Okay. This is the symbolic representation of the galvanic shell. Fine. Let us suppose you have to construct a cell between iron and copper. Okay. Now let us suppose the cell H is Fe plus Ag plus giving Fe, let's say 2 plus Ag. Fine. Now you have to, this is the reaction given. Based on this, you have to give the self representation, or how will you construct the electrochemical cell or the galvanic cell from here. Now, what is happening here? This is the oxygen, and this is the reduction which is taking place. Or these are the couples where the oxidation is taking place, and these are the couples where the reduction is taking place. Fine. Now, what we do is this will be acting as the anode. Okay. So the anode is your Fe is undergoing oxygen as Fe++. Okay. 1 molar, of course. Okay. Separated by solvents, and here Ag plus. Without the balance of the equation is not required here. Okay. But when you have to find out the what we call it Nernst equation, in that case you will have to find out the exact number of electrons also. Okay. Ag plus is getting converted to Ag solid. This is how the cells are represented. Okay. You may find out the cell potential also for this one. Right, this is minus 0.45 volt, I think, and for this one, you think it is, I think, 0.80 volt plus. Okay, you can find out the cell potential for this one. Right? So that's all for today. Nernst equation will be discussing next. Okay, so then have a nice day.